Hello, everyone. Welcome to today's community webcast. This is an API management community webcast as part of our Summer Lunch and Learn series. My name is Kristen Palazzolo. I'm the community manager for CA's API management community. And today's topic is connecting and securing your IoT devices. So we're going to get started in just a minute. I'm recording today's webcast. We'll post the replay to the API management community as well as the slides that Dinesh is going to present today. So this session will discuss key considerations for securing messaging for IoT devices leveraging the CA Mobile App Services solution. You will learn how to use the MQTT protocol to securely communicate and control remote devices. First, Dinesh will be presenting, and then Mike Moore is going to do a quick little demo, and then we will follow that up with some live Q&A. So if anyone has any questions, you can ask your questions in the chat window or the Q&A window, and then we will get to those at the end of Mike's demo, or you can wait until the end and ask a question over the phone line, and I will give you instructions then on how to do that. So thank you, everyone, for joining today, and thank you, Dinesh, for kicking us off.
Thank you, Kristen. Appreciate the introduction and setting the house rules. Good morning, good afternoon, everybody. My name is Dinesh Chandrasekhar. I'm part of the product marketing organization at CA. Work with the API management products and the mobility set of products at CA. Presenting along with me today is Mike Moore. He's a senior principal consultant at CA, and he will be doing the second half of the session today, focusing more on a really cool demo that I don't want you guys to miss. So stay tuned, and we'll go through the series of setting the context kind of slides and then getting into the actual meat of the presentation soon. Now, today's session is really important from what's happening out there in today's digital enterprises, primarily because the channels that enterprises are adopting today to reach out to customers and partners are constantly evolving. I mean, one of the new channels that is predominantly evolving out there is IoT, Internet of Things. So IoT devices come in all shapes and sizes, and it doesn't know any vertical boundaries. You can find them in healthcare, you can find them in retail, and so many other verticals. And every single IoT device has a way to at least help the enterprise gather data or push data out to consumers. What we are going to talk about today is how do you actually connect to such devices? How do you maintain control over such devices when you deploy them as an enterprise into the field, as well as securing them, which is more important that we need to address because that is basically an extension of your enterprise out there. And it's just like any other API or a server or any other control device that you put out there. And so in basic sense, you need to make sure that you have your boundaries and your perimeter secure, and this becomes an extension of your perimeter. So let's talk about that. So in order to set the context of why this is important in IoT devices, why is it so important? Why are we talking about it? As I said, there is an explosion of IoT, in the market today. 3 or 4 years back, if you had asked me, should we consider IoT seriously, how prevalent is it in mainstream, I might have said, I think it'll take probably a few more years to gather mainstream momentum and all that. But today, it's probably already mainstream that in every single customer that we talk to of ours, there's some shape or form of IoT device that has been adopted. So we are talking about in just a matter of mere 4 years from now, 80 billion sensors in devices, 100 million viral connections per minute. That's the kind of growth and transactional rates that we are talking about. And 2.6 million new IoT apps. And this is data gathered from various research sources and stuff. And so it's definitely growing wild. And so enterprises need to make sure that they are able to in a sane way, control them, govern them, and secure them. So the market is definitely, exponential, as we can tell. And we are talking about not just, devices in a specific vertical, as I said, it's across verticals. But the purpose of an enterprise to adopt such IoT devices is not going to be limited to just, creating new business channels. It could be a way of conducting business too. It could be a way of offering it as a service to, specific partners so that they can work hand in hand, creating an ecosystem. It could be about creating a mechanism to sell their services to customers through such devices. So there are lots of different capabilities and possibilities that these devices possess. And, enterprises just need to be more creative, and, more and more new devices are going to be coming out into the market as we go through the next few years in this particular space. IoT is definitely an enabler across, multiple industries. We can talk about various different forms, right? If you consider transportation, shipping, logistics, fleet management, some of the things that, we probably even see day to day, like right from your, fast track devices that you think about today, that you go on your tolls and stuff. Those are essentially devices, but they can only grow smarter. If you put a fast track device and, add an API to it and we make it, remotely controllable, like getting data in, charging it remotely, doing whatnot, based on, what that device is capable of through those kinds of interfaces, you're basically enabling a simpler device that you have today into a smart device, and essentially that will become an IoT device because that possesses an IP, maybe that possesses an interface that you can interface with, connect with and integrate with. So those are all essential things that you'll see in industries like transportation. Of course, planes. I actually have worked with an airport in Switzerland, and this airport has basically all their different doors and gates and everything controlled through IoT devices. And the beauty of this is that they can actually control the gates and the doors right from one single control center based on which plane is coming through. If the plane is coming from international route, they can actually route the passengers through a specific set of gates into an immigration area, for instance. If the plane has come from domestic, then they need to go through a domestic baggage claim for that particular airline. So they can actually route the passengers remotely from one single control center based on who's coming in. And of course, it doesn't have to be a manual process as well. It can be intelligent enough that based on which airline, which plane has come in through, that these gates and the doors can be automatically done as well. And beyond that, of course, the plane delays and automatic notifications to passengers, everything becomes more seamless when you adopt such devices and such patterns. And you'll also notice that there's a parallel growth in the mobile space as well, because as much as there is growth in IoT, every single connectivity point can also be exposed as an interface on the mobile side. So you have a mobile app, you can look at it, and if you're a service personnel, you can look at these gates and doors and you can control them from your mobile device if need to. Or if you're like a passenger trying to look for flight notifications, delays, and check-ins and whatnot, you can do all that as well from your mobile device. So there is a lot of connectivity and parallels between the IoT and the mobile space that you will see. If you look at healthcare, phenomenal space for IoT capabilities. Patient biometric monitoring, surgical equipments that are self-aware, diagnostic devices that can actually report errors automatically to the service department with logs and everything, so that it saves upon service personnel actually having to come out to the device and understanding what has actually went wrong and all that. So everything can be automated again through devices that are self-aware. That's again a space that we'll probably even talk about more, self-aware and self-healing kind of devices that are going to grow more in the next several years in various verticals like this. If you look at consumer devices, that's very common. That's something that you're noticing in your day-to-day life. You have Nest thermostats, you have connected cars, like all the electric cars that are coming in today. Everything has several computers on board that are talking to each other, that are connected to various systems. The HVAC system is connecting to the central computer on board through APIs and other mechanisms. So there is a lot of capability. And again, going back to the mobile scenario as well. You can now check for your battery on your electric vehicle right from your mobile phone. You can find out, if it is like, 61% charge. That basically is an essence of the mobile device communicating with the interface on your car. That basically tells the mobile device as to how much battery is left. So all this kind of connectivity is possible as well through IoT and mobile alignment. Manufacturing. Now, but before I jump into manufacturing, maybe I should tell you an interesting story that I actually saw on the consumer front as well. We were shopping for a refrigerator recently, and we went out to the local appliance store, and we actually found a Samsung fridge out there. And it's probably something that you have heard of as well. But it was fascinating to see this in action, right there. This is like one of their state-of-the-art, new ones, cost like $5,000 or something like that. But the beauty behind that is it has these cameras that are inside the fridge. So if I'm out at the grocery store and, of course I'm married and I would call my wife and say, what do you need, so I can get that. So that would definitely be the case. But, if I'm out there by myself and I don't have anybody to call home, I can actually look inside the fridge to find out what, is the state of affairs inside the fridge. Like, have I run out of milk? Do I need vegetables? Do I need this? Do I need butter? So I can actually find all that out right from my mobile phone by looking inside the fridge and actually shopping based on that. And of course, the fridge can also order things for you. If I run out of milk, the fridge can actually intelligently order it through the internet, because it's all connected through the internet. There are IP for the camera, IP for the fridge, everything is there. So this is like, IoT getting into the future. So this is only going to get better and better, that everything is connected, that devices like these can automatically enable lifestyles for you that you didn't think were possible. So those are the kinds of things that we are looking at. Finally, manufacturing, telco, and there are more such industries like this. Utility, that's another space. I was there at a utility company just like 2 days ago. I was delivering a talk about smart grids and IoT, and this is a fascinating area again, because every single utility company out there is jumping on to the smart grid wagon, if they haven't already, because that space, has been evolving over the last several years now. We already had a grid, the grid is like old, dying, now we are trying to make it smart. So there is like deployment of like, smart meters everywhere, immense amount of smart devices, and beyond just smart meters, like smart plugs and smart switches and whatnot. So every one of those has the capability to like, report upon data, stream data back to the central store, receive data. Like, for instance, if I were to like deploy a patch out to a smart meter, I can do that through whatever protocol that is defined to like access that particular device. And the device itself can like report upon consumer usage, which I can then, see on my mobile device. So there are a lot of such, connectivity points there. And, it's a fascinating space again in the utility vertical, as well as to how smart grids, IoT, and APIs are like coming together in the context of, again, mobility as well. So fascinating space. Every single vertical has, usage for IoT and beyond. The reason why I'm telling you all this is that, again, you need to understand that there are various attendees here, obviously, in this particular webinar, and each one of you have come from a different vertical. And I just want to throw out the flavor of, the different kinds of scenarios and use cases out there, that you can draw some of your own extensions to what I'm talking about, and understand that, there are IoT devices abound, and we need to start thinking about securing them and governing them and all that. So we'll talk about some of the challenges as well. So if we talk about use cases specifically in a retail context, in an enhanced shopper experience, I think I spoke about the fridge, so let's skip that for a second. But let's talk about, another, scenario that is near and dear to my heart, because, that's something that I've pitched about for quite some time, and this space is real, refrigerated trucks for like carrying perishable goods from one end of the country to another. The supplier might be in one end, and the retailer that needs those goods might be in the other end of the country. And so these refrigerated trucks basically carry perishable goods like milk and, meat and whatnot, everything from one end of the country to the other end. Now, given that, there is a lot of room for error in those kinds of transport mechanisms because goods could get shifted, and within the truck, there are like temperature zones, and if the zones get, to have altered temperatures because of the movement of goods inside the truck, the goods could get basically spoiled because the milk is like stored at a higher temperature or whatnot. So getting to know about the real-time nature of such anomalies, such issues, and fixing them right away will actually prevent huge losses in the businesses instead of the driver having to actually realize that he drives all the way across the country and the goods inside the truck were actually spoiled. And there are serious FDA regulations and implications in terms of penalties and all that to this as well. And Mike has a really cool demo on this, and he'll spend some more time on talking about this. So definitely wait for it in a few more minutes. He'll get to that. Healthcare, we talked about biometric sensors, but patient monitoring, is definitely going to be one of those spaces that is going to explode in terms of IoT devices. Because if you consider, there are only so much that nurses and doctors can do in terms of understanding what the various patterns are, how the vitals are. But with so many different hospitals coming up, so many, patients, getting admitted on a day-to-day basis, it becomes, humanly, impossible to track every single thing and do all this stuff. So these kinds of sensors actually make life easier for nurses and doctors, thereby monitoring not only just the vitals, but also understanding patterns in those vitals, trying to see for this kind of a condition, for this kind of a patient, what is the normal, or mean or average for that particular vital, if it be blood pressure, or if it be heart rate, systolic heart rate or whatever, and trying to understand that and maintaining that throughout. And if there is an abnormality in terms of the patient basically suddenly having a seizure or something like that, and the vitals basically going up or down, that would trigger off a notification, a pager notification, cell phone text or whatever be the case, whatever be the device of choice of the nurses and doctors. They will get that notification instantly so that they can go look into that patient. That again, makes a lot of room for IoT applications right there. Personalized hospital experiences, if you consider hospitals, they are evolving into the state-of-the-art kind of organizations where they are personalizing your experience. If you're there are some cancer hospitals, particularly for children, that actually take this to a level of treating the patients with utmost care, that the child, whenever they come back for a relapse and they come back for repeat chemo or something like that, the room can be completely customized to that particular child's needs. The colored lights in the room, the child wants green lights across the ceiling and all that. They can control that because every single light has an IP, and you can control all that from your device. The sound or the music in the room, the devices inside the room, like for instance a TV screen basically will display the information about a doctor that is actually walking in to that particular room. Most of the times you don't even know which doctor walks in because there is 4 different shifts in a particular day, and there are a lot of different doctors come and walk in, check the patient and go, and you have no clue who's coming in, what they're saying. But it kind of gives up a heads up on the screen saying Dr. So-and-so is walking in and he's a specialist for so-and-so and all that. And this happens because the doctor has a tag, and the tag is basically read at the entrance by a reader, and that immediately prompts a notification up on the screen. And so, those kinds of connectivity happen, and making it a lot more easier for the child as well as the family to experience the hospital as though it's more comfortable rather than being like a painful extension of their already miserable state of affairs there. So it's definitely helpful for them to have such an experience. Energy utility, I won't spend more time on this because then I think we touched on that, we talked about it. But think about connected ecosystems is where I was going with this, where not only are you talking about helping the utility companies with smart grids and all that, but connected homes, basically interfacing with connected utility companies. For instance, if a pattern in my home, the thermostat basically understands that I'm basically at home from before 9 or after 6, and it has to adjust the temperature based on that. It communicates, that usage pattern to my utility company. The utility company can then adjust the rates accordingly and send back, appropriate rate discounts and all that back to me. So those kinds of things can, communications between IoT devices across systems can also happen. Those are things that are potentially bound to happen to create more connected ecosystems. So having said all of this, then it seems like very, rosy picture, right? So what is the problem here? What are some of the challenges that could happen when we start thinking about adopting such IoT devices into our enterprises? Onboarding. So this is first step of, order of business that we need to clarify, because when you start thinking about IoT devices that you deploy, you consider the hospital scenario or the utility scenario, whatever be the use case for you, you are talking about registering the device that you can track, you can maintain, you can manage, you can govern and secure on an ongoing basis. So you need to make sure that there is some kind of a registration process for the device. But registering like millions of devices can also take time. So, which means then you need to consider like self-registration processes. Can the device automatically like connect up to your network in a way and can, do self-registration? How do you like, do updates and fixes to that particular device? That's going to be, again, a question for the onboarding process too. Connectivity. This is, again, a topic for today where we will be talking about how does this device integrate with the enterprise? How do you connect with such devices? What kind of protocols do you need to deal with? And how do you exchange data back and forth? That's, again, a very important topic because not only is connectivity important, but how do you handle the data that is coming in or out of such devices? Governance. Device management and ownership is going to be a topic by itself because when you talk about millions of devices, you're talking about SLAs, you're talking about when to actually do maintenance, when you can bring them down, can you substitute them with backups, can you replace them, what is the replacement process, can you send them updates and fixes remotely, how do you do all that? And then on top of that, rogue devices, can any other device be plugged into your network and fake as though it's part of your network? That's again a security question, but it's also about governance as to like, is there a process where you can onboard the devices in a way that, only there is an approval process or an authorization that, enables that device to be added onto your network. Too much data. So until now, there are workflows that have helped us in getting data out of systems in a certain pattern, like, daily, mornings, evenings, whatever be the pattern. But with sensors and IoT devices like that, they're going to like stream data on a much more quicker and periodical manner where it's no longer like, on a daily basis, it's more like, every half an hour, every 1 hour kind of, or even shorter for like some of the verticals where they're doing testing data and the testing sensors need to send out information. So how do you handle all of that data? Because now you're getting data not like, as a data point, but more like data streams. So we are now talking about big data. We are not talking about like, huge volumes of data, and you need to be able to make sense out of that data. That is more important. How do you like manage all the data points? How do you identify patterns within that? And how do you do like real-time analysis so that you can make some intelligent decision making on such data? You can consider patient monitoring for that, as an example that we talked about. If I'm constantly getting like, vitals information of a specific patient, that by itself is not helpful. But if I can understand a pattern in that and say, these are normal points, but I need to be notified only when there is abnormality, when there is an outlier in that particular data, that would be helpful for me. So that kind of real-time analysis is going to be helpful because now I can go immediately to that patient's room and help out. Same thing with refrigerated trucks that we talked about. Helping out patterns of the sensors temperature readings is one thing, but the pattern to like identify that abnormality or going above or below a specific threshold would actually help in preventing a loss of perishable goods. Security. Now, key topic, I just put it at the very end so that I can emphasize it a lot more because we are now talking about not just an enterprise level security at the perimeter. We are not just talking about a system where you're like securing it by adding a gateway in front. We are not just talking about an API that is like secured by a OAuth token or whatever. We are talking about like millions of devices that are connected, and we are talking about device level security, right? How do you like manage that? You can put still a gateway around it. You can probably like stream clusters of devices through a particular gateway. You can do lots of different patterns, but the architectural patterns that you've been used to are going to be much different than what an IoT environment will want. So those kinds of things will change. Open APIs. Because of the nature of such devices, there are various different protocols and all that you might encounter as to how data can be exchanged back and forth as well. But there are APIs that are bound to be established in some devices, in these devices as well, where you can call into that API and actually get or put data back and forth into such devices as well. And one such scenario around that would be something that I will be talking about next, about connected cars, where you can have third-party components put into to create a particular entity, like a connected car by itself, like an electric car. It's not made up all by like one manufacturer. All the different devices and the APIs in them are like written by one particular company, like Nissan or somebody like that. It is going to be like a add up, put together scenario of various different manufacturers coming up with like, I got my HVAC system here, I got the battery component coming in from a different company, I got this from a different company. So you basically put together as a manufacturer all these different components from various suppliers and parts manufacturers, and you create this connected car, which means now security is distributed. Now you don't have basically control over a lot of different things that you need to like identify which one has open APIs, which one has like open endpoints that I can that I should secure before I release this car out into the world. So those are things that you need to do. And then SDKs, that's again the order of the day when you start thinking about ease of use of like having to like work with such devices and securing them. So that is something that we'll talk about as well in the demo. A quick example on Nissan Leaf. A few months back, there was a hack into Nissan Leaf. There was an ethical hacker that basically realized that the HVAC system inside the Nissan Leaf had an API that was unsecure, like how you're looking at here down below on the screen, where it took in like a VIN number in the URI, and so the hacker basically said, well, what if I substitute that VIN number with a different VIN number? And instantly he was able to like access the HVAC system of a different car without any kind of security token or whatnot. So it was very easy to like basically get into the not just understanding the temperature controls and tuning them from remotely of a specific car, but you can also understand the driving patterns of that car, where the car has been and all that. So with one specific hole like that, you can basically get into a lot of different systems within the entire ecosystem and control the car. And we've heard of Jeep hacks where the car was like shut down right in the middle of the road remotely by a hacker. So there are lots of things like this that happen on a day-to-day basis, and security needs to be considered for each and every one of these IoT devices that we put out there. So in terms of development challenges, as I said before, there are various different types of protocols that are available where devices can communicate with your internal systems. You might choose to again put like device gateways where there is a cluster of devices communicating with a gateway, and that internally communicates, does all your protocol translation, mediation, everything from the device level protocols to your internal systems, and could be like REST-based interfaces and all that. That could allow for like data collection and integration with your internal applications and services as well. So the challenges in terms of developing them are abound in terms of not just security alone, but how do you connect with these various different protocols? How do you get data in and out of these devices? How do I translate those types of protocols and data into my internal systems? All those would matter. And leveraging something like an internal client SDK that eases up frameworks can actually help in this particular scenario. So I'm going to skip ahead and talk about, and this is basically the same representation, but getting into details about what some of the IoT devices that you need to consider as well. I'll share the slides as well. You can definitely take a look at them in terms of what these services that you need to think about beyond security as well, orchestration and management, control, provisioning, everything, right? So we went through a whole bunch of them. So this is like a much more clearer picture of what that architecture could look like and what are the things that you need to consider. So how does CA API management help, right? In terms of digital transformation, we talked about omnichannel delivery, not just mobile, IoT, and all that. But there are, various different, other things to consider as well in terms of digital transformation that you need to consider, like data security risks, slow app development, monetization, if you're not able to monetize on your open APIs on the IoT devices that you, put out there. How do you do all that? So CA API management has like, 4 broad themes with its portfolio of product set. Integrating your internal existing systems into more modern interfaces, APIs, and other channels like omnichannels like mobile and IoT. Securing the enterprise with from various types of threats and vulnerabilities, that's something that CA does as a #1 leader in this particular space. Accelerating mobile and IoT development. This is going to be the topic that we're going to spend a little bit of time on today in the demo as well, because we talked about IoT so much that, we are going to talk about what CA brings about in terms of a solution to building such IoT and mobile apps as well. And then, of course, the monetization of such APIs that you expose with partners. How do I, make money out of that as well? It's one thing to create and leave out an API for partners to consume, but if you see more and more consumption, you're going to have a lot of maintenance as well. So in order to compensate for that, you need to be able to monetize on that too. So the connected ecosystems that we talked about, creating extended arms of your organization, mobility initiatives, bringing in cloud, mobile, IoT, everything together in the form of into your enterprise from external sources, enabling developers to create more and more apps from your interfaces that you expose. Everything is enabled through CA API management. So the products that we are going to be talking about today and in the demo as well would be the gateway, which acts as your entry point for all different types of in and out kind of API interfaces. We won't be talking about the live API creator, but I just want to throw it out there so you understand that that is an enablement capability where you can expose data points from your backend systems as APIs instantly, which can then be served up through the gateway for your external consumption as well. So if you create a mobile app and you need to get data from your backend sources, you can do so with these APIs that are created in the backend. And then we'll talk about the mobile app services, which help you in building mobile applications, connecting with IoT devices, enabling MQTT, and communicating with the IoT devices or MQTT. How the client SDK of mobile app services actually helps in doing all that. So that's pretty much what I had, and I'm going to ask Mike to jump in and start talking about his demo and help us with showcasing some of his cool stuff. Mike, did you want to present the slides on your end?
That would be fine. Let me go ahead and get those up for you.
Okay. I saw somebody move the presentation rights from my end to your end.
That's all right. We will make it work.
All right.
There we go.
Cool.
So my name is Mike Moore. I'm a principal consultant for our API management group. And today I've focused on a very specific use case that Dinesh just talked about on the refrigerated truck monitoring. And I'm going to talk a little bit about the architecture. We'll talk about the hardware. We'll talk about security. And we'll just look at the whole overall mobile app as well. So without any further ado, we're going to just dive into this. So the premise that we're looking at here is temperature-controlled shipping containers, right? So a refrigerated truck is really nothing more than a truck with a refrigerated container on top of it. And where our big focus is for something like this is inside the actual container itself. So we want to look at maybe a couple of different points. And in this instance, we're going to look at the front of the truck and the back of the truck for simplicity's sake. And then we're going to look at 2 localized RFID readers, or near-field communication readers, to look at acceptable temperature ranges for whatever might be in the truck. So if you've got, butter in one end and you've got milk in the other end, or you've got, a steak at the other side, they're going to be at different temperatures, or you're going to want to keep them at different temperatures perhaps. And so being able to monitor that and control that is very important. So you need to be able to understand that climate inside this container. And then you need the visualization, right? You need something that the driver doesn't have to look at a set of temperatures and go, is that right? Is that off? I'm not sure. So we need to visualize this data somehow, and we need to be able to send that maybe to ops, send that to maybe the end customer wants to look at the profile of all of the data that's been collected from the time the shipping container left to the time the shipping container got to its destination, to make sure that at no point did the temperature exceed a certain amount for a certain period of time. You also want to maybe look at making these systems wireless, right? Because you don't want to have to buy brand new containers for everything you do. So you want to be able to retrofit your existing containers, right? We save on cost, and we don't need to, switch everything out. There's a lot of complexity there. And then we really want to be able to secure that data. Depending on what you're shipping, I used to do a lot of work with folks like Raytheon, and they shipped missiles in trucks, right, live warhead type stuff. And when they collected data on that, there was no doubt that they had to secure that data. And typically speaking, you don't want your data just being transmitted all over the place for just about anyone to see, because there's always someone out there looking to do bad things with your data or your system. So being able to secure that appropriately is definitely the way to go. So this is a bit of a, narrowed down scenario, what we're looking at here. So the way this is set up is I have a gateway running here. On the front end, we have a TLS connection that has our mobile app services and mobile API gateway set up on the API gateway itself. I've written a mobile app for iOS that uses the mobile app services client, and we'll take a look at the SDK there and how that's used. And I've also set up 2 Arduino-based devices with 2 RFID readers and 2 temperature sensors that are publishing data to the gateway. Now, the gateway is actually pushing this data out to MQTT. I have a Mosquito client running back here as well. And that data is being published to 2 queues, one being a temperature queue, one being an RFID tag queue. And the app itself is subscribing to these queues and listening for updates, which are being passed and relayed back through it in a secure manner to the gateway. And if you'll notice, all of our connections here are run through TLS, and specifically we're running through TLS 1.2. But what's going on here is at no point between the device and the gateway, or the gateway and the broker, or between the device and the gateway itself, there is no unsecured connection here, right? So all of your data is secured. There's quite a bit going on, and we'll explain a little bit more about registration of devices and things as we look at the demo. And then finally, I have an LDAP on the back end, but you could use Active Directory, Oracle, SiteMinder. It doesn't necessarily matter what you use, but identification, authorization, all of that good stuff is fairly important when you're trying to lock down and secure a solution. So with that, we're going to take a quick look at our setup here. So this is our simulated truck. We've got 2 ends of our truck, one with beer, one with bacon, and I've added in another one for Dinesh here with milk. So we're going to take a look at that. But what's going on is these 2 devices are transmitting wirelessly to my network here, publishing out to our gateway through that secure connection. And as we take a look at the app, you'll see we'll switch out the RFID tags. We're going to be taking a look at different, actually different types of food groups, and we've got different settings for their, different settings for their temperature ranges, right? So we have an upper limit and a lower limit, and we'll take a look at some visualization there as well. So with that, we're just going to dive right in here. So essentially what we're going to get into here is this quick little app I've written. It took an hour or 2 to really write this whole thing. It was very quick. I am by no means a superb iOS developer, but I know enough to be dangerous. So what I've designed here is a quick, login screen, and then we move to a monitoring solution that hooks into our MQTT server. And this is using our mobile app services SDK. Now, just to point out a couple of quick things, as the app runs, what's happening in the background, and you guys will never see this because it's so very quick, the app is actually registering with our gateway which actually registers your mobile device. The same protocol, the same flow and format could be assigned actually to your IoT devices as well. We've opened up APIs, and so you can get in and create this unique device registration. So each device on your network, if you've got 10 devices or you've got 10 million devices, we can go ahead and as each device connects to your network, we can register it and actually create X509 certificates. So we've got a PKI infrastructure that allows each device to be authenticated and registered on its own, and the mobile app works the exact same way. So what's going to happen, we launch the app, all of that registration process takes, it happens under the hood very quickly. And all of that happens right here at the very beginning of our code. And it happens in this very brief little segment of code, right, which is maz.start, which is mobile app services. And all we do is we start the framework. There's a configuration file that's defined here. It utilizes some different OAuth tokens and OpenID Connect, and we go out and we register our device, and now we have a secure channel back to the gateway. From there, we move into our login controller, where we'll log in with our user, which is, again, a very brief, very simple mosuser.login with the username. We pass that on. We get a registration or not. And then once we've registered, we get a login authentication. If we're good, we move forward to our secure data controller here. And from here, I just want to point out a couple of quick things. We're actually, as we log into here, we've got a very quick piece of code where we're going to connect with the gateway itself that I've got. If you'll notice, we're connecting with TLS. We've got port 8883. And then we're actually subscribing to two channels, right? We're subscribing to a feed's temperature and a feed's RFID. So what you're going to see here as things happen in this app is we've connected to the gateway, we've connected to MQTT, we've subscribed to these channels, and our two devices are constantly publishing data out. So with that, let's go ahead and run our application. And you can take a look here. We're live. So no strings being pulled here. We're already logged in here, so the app has detected that. We're going to go ahead and unlock our token with a touch ID. So that's fine. We'll go ahead and move forward. And as you can see, our truck is now empty, right? There are no cards on top of our truck. So these are the two temperature readings we've got. We can go ahead and take a look at maybe raising the temperature on one side or the other. As you can see, I've got my finger on the temperature sensor here, and the temperature is rising on the right side of our app. Now, again, all this data is very secured all the way in, all the way out, right? So there's no likelihood of anybody sniffing this traffic, and if they are, they're not really getting much out of it. And from here, again, we're able to look at different points of data. So what we're going to do, I'm going to go ahead and say, we're going to load this truck up here. I'm going to put some milk in there. Well, milk's got a pretty low temperature if you want it to stay good. So what you're going to notice is our truck here turns red, right? We have some settings. We're looking at that data as we come in. And in fact, I've set up just a quick case for this demo to set different temperature ranges, right? And we'll notice that our milk temperature range is 34 to 38 degrees. And as much as I love being cold, I don't have a refrigerator here we can stick things in. So what we're going to do is we'll just assume that's fine. But we can see these other temperature ranges here that range between 72 and 75, which is pretty reasonable for where we're sitting. So I'm going to go ahead and take that off. We're going to put some bacon down here. There we go. And then we'll put some beer in here. We're going to put the two main food groups right down here on our truck. And what you'll notice is we have a different temperature range, right, for our bacon. So as our bacon reaches 75 degrees, we're going to have to, start looking at that and going, there's a point at which it's going to start to get too hot, right? So let's see here if I can get this up to 75 degrees. We've got a big fan running in here, so it takes a second sometimes. Let's go do that. There we go. That'll do it. So now we can get an alert and a notification. And one of the things that I'd love to be able to show off here that I can't because we're on a simulator is we could have the API gateway sitting listening to this queue the whole time looking for specific data sets. And as Dinesh mentioned, looking at data that says, you know, we're looking at a milk temperature coming in. We know it's too hot. We need to alert somebody. So maybe we can send a push notification. Maybe we can send an email out. Unfortunately, as I mentioned with the simulators, we can't send push notifications. Apple simply does not allow that in the test framework. But these are things that we could do on the gateway side. Before the data even reaches the queue, we can collect it from the device, test for a certain set of you know, criteria, and if we find that, we can fire off these notifications, get somebody's attention, and get them to maybe fixing the truck or removing the item or doing whatever it is they need to do. So with that, that concludes the demo. So I will go ahead and pass that back to Kristen, I believe. Or is that back to Dinesh?
Yeah, thank you. This is one of the most fun demos I've seen. All right, I'm going to kick off a poll. So if you guys can please rate today's webcast, that would be awesome. So that poll will remain open for the next 5 minutes. And now we're going to open it up for live Q&A as well. So if you have a question for Dinesh or Mike, you can ask it in the Q&A panel or the chat window, or you can unmute your line if you're dialed in via your phone by pressing #6 or *6. And if you're listening to the audio over your computer, you can click the icon that looks like a phone with a question mark in WebEx, and I can enable your microphone to work as well if you'd like to ask a question there. All right. Lots of people answering the poll, so thanks, guys. I don't see any questions, though. It's a Pokemon Go themed poll, if you guys haven't already noticed that. Oh, here's something in the chat. Okay. No. Got a question. I know you already mentioned about security aspects of it, but I don't think with the fast scalability of IoT, security will pose to become a serious threat, especially with more and more exposure over many devices, et cetera.
So Dinesh, I'll take that if that's all right.
Sure.
So my take on that is, you know, as I was talking about, and as we were looking at that device registration concept, if you got a device and if you can self-register that device and manage your devices in such a way that you've created this great PKI type infrastructure, you definitely lessen the risk of, you know, missing a device or missing some information, and you're always guaranteeing a secure channel back from each device. So not only can you track each device, but we can disable devices, we can update devices, we can do a lot of things around making sure that things are up to date, things are secure. You know, and one of the things that we haven't touched on here and haven't talked about is, you know, there's a huge problem with updating devices and people keeping things up to date, but as people are coming around more and more to over-the-air update type stuff with FPGAs and better firmware type operations, what I think we'll see is as devices are registered, we can start to track who's up to date, and then we can start to either force devices to update or deny access to devices that don't have the proper updates or the proper security levels and channels. So I think, yeah, absolutely, as devices grow in number, you'll pose a greater threat, but if you manage it properly, you can mitigate almost all of it.
Great point.
Speak to the suitability of this technology stack for modernization of legacy systems. Are there any specific approaches you've seen that work well?
Ask the question again, Kristen. I didn't hear the first part.
Can you speak to the suitability of this technology stack for modernization of legacy systems? Are there any specific approaches that you've seen work well?
Oh, yeah. So if you look at the API gateway by itself, since you asked about the technology stack, it has the capability to connect up with legacy systems and expose APIs and all that. We talked about the live API creator being able to expose APIs from back SQL, NoSQL, whatnot. But the capability to expose either functionality or data from these legacy systems as APIs by itself extends to the nature of reaching out to other aspects of your enterprise architecture through these APIs. So thereby you're creating orchestrations, you're able to create transformations from one data structure to another. So all this in a little ESB-esque kind of a way, leads to more modernization of such legacy applications. Of course, there are companies that already have an ESB in place that help in connecting these legacy systems because that's what ESBs are meant to do. But you can now take those connections from the ESB as well and connect them to more modern digital enterprises initiatives like mobile and IoT and all that, thereby extending your legacy data into such newer forms of digital enterprises, which ESBs don't tend to do, because they are more tend to be in the back end, trying to connect up with the legacy applications as well. So this is something that has been talked about even by Gartner, over the last several years as to how such API management stacks can extend these legacy applications into more modern frameworks. Good questions.
Yeah, good questions. I don't see any other right now. Anyone wanted to ask one over the phone? All right, well, if you think of any other questions, you can reply to the follow-up email that I will send later today, or you can post it in the CA API management community, which is at ca.com/talkapis, and I'll make sure it gets to Dinesh and Mike. So thank you guys so much for joining today and for doing this webcast, and we'll look forward to another webcast next week.
Thank you all.
Thanks, everyone.